Hello and welcome to day one of IJS STEAM Week. Welcome to the first wow of STEAM Week 2020. In this experiment, we are going to be marvelling over magnetism. Before we begin, let's look at some background knowledge. What is magnetism? I'm sure you all have magnets at home. I like to collect them when I go on holiday and decorate my fridge with them. But what is a magnet? A magnet is an object which has two poles, a north pole and a south pole. When opposite poles are moved near each other, they attract. An invisible force pulls them together. When the same poles are moved near each other, for example, a south pole and a south pole, they repel. The same invisible force pushes them away. But what is the invisible force? It is called magnetic force. How is a magnetic field created? The magnetic force from the poles of a magnet create an invisible area around the magnet known as the magnetic field. If a magnetic object is placed in this field, the poles of the magnet will either pull it towards the magnet, attract, or push it away, repel. Not all objects are magnetic. Only objects made with nickel, cobalt, iron, or steel will react to the magnetic field. Watch the video to see what happens when iron filings are placed near a magnet. As the iron filings are placed near the magnetic field, you can start to see them moving towards the poles of the magnet. Each tiny iron filing has its own north and south pole, which are either being attracted or repelled by the magnet. Now you know a little more about magnets and magnetic fields, we are going to have a go at making our own magnetic compasses. I am joined by a surprise guest to help me out. Right, hello. We are going to now show you how to make a magnetic compass. And I'm joined by my very special guest, Mrs. Warner.
Hi everyone.
Okay, so we just checked we've got everything we need. First of all, a non-metallic bowl, so plastic or glass with some water in it. Excellent.
Yep.
Put mine here too. A needle, or I've used a paper clip that I've unbent. Excellent.
I've got a needle.
We need either a magnet, or I am going to use the strip down the inside of my fridge door.
I've got a magnet, fridge magnet, quite a strong one.
Excellent.
Mouse, I think she is. Bring me luck. Hopefully it'll work.
And then something to place your needle or paper clip on. I've got a slice of cork here.
Now, I didn't have any of what you suggested, so I've used an old container and I've cut a slice out. But in the meantime, my son's come along and moved my container, so I've had to improvise. And now I've got a lid, just a plastic lid that I've found. So anything that's just quite light and not water soluble should be okay, anything that you can find.
Excellent. Good use of recycling as well. Now, if you are cutting something, make sure that you ask an adult for help. Very important. Okay, so the first thing you need to do is take your needle and you're going to rub it in the same direction down or across your magnet about 50 times. That's 50. If you can, I don't know if you can see me doing it, but try and rotate your needle as you go so the whole thing is magnetised.
Yeah, so if you keep twisting it as you're doing it, yeah?
That's it, yeah. Okay, so 50.
Go.
Go. 1, 2, 3, 4, 5, 6, 7.
First 10 go.
9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23,
20.
26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36,
30. Nearly there.
39,
It just
40,
works.
1, 2, 3, 4, 45. 50. Right. How are you doing, Lorna?
Good, I'm done.
Excellent. Brilliant.
Done, I'm all ready.
Excellent. If you can, try and remember which end of your needle was the bit that was rubbed if you didn't manage to do the whole thing. Okay? So now your needle is, yes. Now it's magnetised. So we're going to place it onto the cork. Try and balance it. Okay? And then very carefully pop it on the water. Now, when you're watching this video at home, I'd like you to pause at this moment and just have a little think about some questions. What do you think is going to happen to the needle? What do you think will happen if we move our compasses near to something electrical or near to something that is magnetic? So that's anything containing iron, nickel, cobalt, or steel. Okay, so have a little think, and we're just going to watch and wait for our needles to settle down. Hopefully you should notice something.
I'm going to get my compass.
Right. Now, I think mine's settled down. Has yours, Mrs. Warner?
Mm-hmm.
Excellent. Can you confirm, is it pointing in the direction of north?
It is.
I don't know if I can show you all this. Hopefully you can now see that my compass is pointing in the same direction as my compass on my phone there. You can see the red arrow is pointing in the same direction, which means that we have found magnetic north.
I don't move mine. Can you? I mean, you can see mine, can you?
Oh yeah, I think so, yes.
Can you see the... Oh,
Yeah.
it's moving now. I don't know if mine is in the... Oh, yes, it is, yeah. Can you see? You see? Ish? You
Yeah.
might have to take my word for it.
So,
Yeah. Oh, isn't that clever?
it is, isn't it? And I was playing around with this last night and moving it all around the house. And it was always then pointing back to north, no matter where I put it. On the floor, high up, moving around, it always found north again. Which I thought was really, really clever.
Very good. What would happen if you swirled? So could you put your finger in it and swirl it, and then in theory it would always go back? If I did that,
yes, we have a go.
Yeah.
Right, so mine's moved. Oh.
But it should end up there. In theory. It might take a while. That might be something you might want to do yourselves if you've got time. I keep making funny faces because I'm just like, it's unusual for science investigations to actually work.
So there might be all sorts of different things you can try with your homemade compass now. And remember, from our background information, wherever the needle is pointing to north, that end of the magnet is south, because the opposites attract. There's your cue.
Yeah, mine just stopped again, and it's done.
It's gone back to the same direction.
It's a different bowl, but actually it's pointing north. See that there? It's a different place in the bowl, the needle is, but it's still pointing right. Still pointing north.
Excellent.
Okay.
Right.
So, yeah, we've proved it. So we've just had a little bit of proof there.
Mine's still going. It's slowing down gently. So
it's funny how it's just in the, in that direction. All things are pointing that way. That's our north.
My north is pointing. Where is north? North's that way at the minute. For me.
Oh.
So we hope you have fun being careful making your compass, and we look forward to seeing all of your findings afterwards. Remember, you can tweet them or send them into class teacher. But we look forward to seeing what you come up with. Yes.
And don't worry if you haven't got the right equipment. Just have a look around your house, whatever you can use. It doesn't have to look exactly the same as ours, but just have a go. And everybody's got a fridge, so you can just stroke it down the side of your fridge, if nothing else. So yeah, have a go.
Enjoy.
Yeah, thank you.
Thank you, Lorna. Bye.
Bye.
So, what was happening to the magnet? Do you remember I said that a magnet has a north pole and a south pole? Well, the Earth has a magnetic north pole and a magnetic south pole, so it is like a giant magnet. Because of the magnetic poles, there is a magnetic field surrounding the Earth. When the needle moves, it means that the needle is being affected by the Earth's magnetic field. The south pole of your needle is being pulled towards the Earth's magnetic north pole, which results in us finding the direction we need. We can check this by using a magnetic compass alongside our made compass, or you can use the sun. At midday, the sun is in the south, so one end of the needle should be pointing towards it, whilst the other end will be pointing to north. Now it's your turn to have a go at making a magnetic compass. Observe the needle carefully to see how it moves and what makes it change direction. As an additional challenge, we want you to use your compass to find out which direction your house points and find out which direction you walk to school from your house. We look forward to seeing your compasses and hearing how they have helped you navigate around your houses. Now it's time for our engineering challenge. This challenge focuses on the magic of light. First of all, let's look at a little background knowledge. So, what is light? We use it all the time, but do you ever think about how it works? Where does light come from? Light is a type of energy which allows us to see. There are lots of different sources of light. Our main source of light is the sun, but we can also get natural light from a fire or the stars. Nowadays, there are also man-made sources of light, such as torches or light bulbs. Is the moon a source of light? Although we can use it to see, especially on a clear night with a full moon, it is not a source of light. The moon reflects the light of the sun, so even at night, the sun can be a source of light. How do we see colour? Light is made up of a spectrum of colours. When the colours are combined, they create white light. White light can be split into 7 colours: red, orange, yellow, green, blue, indigo, violet. Sound familiar? That's right, these are the colours of the rainbow. That's because a rainbow is created when white light is split through raindrops. When white light hits an object, some of the colours are absorbed. We don't see these colours, and some are reflected. These are the colours we see. So a red apple appears red because all of the other coloured lights have been absorbed except the red light. On to your challenge. There are 3 primary colours of light: red, blue, and yellow. You might have learnt about these in art. When 2 or more colours are mixed together, a new colour is created. The same applies to light. Your challenge is to construct a light spinner and observe which combinations of colours create new colours of light.
Hello. Now I'm going to show you how to create your colour wheel so that you can investigate the magic of light. Now this is our engineering challenge, so it involves us constructing something and designing something. So here we go. You will need paper, card. I've just got an old cereal box, something circular to draw around, something to draw around it with. You will need some scissors, a ruler, a protractor, and a piece of string. Okay, now this string needs to be the length of your arm span. So that measures from one fingertip on one hand all the way along to the fingertip on the other hand. So it's a nice long piece of string. You could use thread. I've just raided my gift wrap box and just found something that you can wrap presents up with. Okay, so that's what you will need. First step then, draw around your something circular onto your piece of paper. I'm just going to draw around it in pen for the moment so that you can see it more easily. So there you go. There's my circle. Then you're going to do the same again in your card, which I have already done. Once you've done those, you need to very carefully cut them out. Try and keep as close to the line as possible. There we go, there's my circle. And then we have our card as well. Now, when you're cutting from a big box, don't try and cut through the whole box. Cut a section around it first, make it smaller, and therefore more manageable. Okay, much easier to cut out from that than from the whole box. Again, cutting very carefully around your line. If anything, we want the card to be slightly bigger than the paper. Okay, right. So we have paper, card. So the next thing that we need to do is start working out our 6 equal sections on our piece of paper. So first of all, I'm going to find the midpoint. I'm going to fold it in half. Okay, need that line definitely, making it into a semicircle. And I'm going to fold again, but I'm only really interested in this corner. So you don't need to flatten down the side, just want that corner. Okay, then we can unfurl it. With your ruler, you can draw along the line that creates the semicircle. Again, I'm just doing it in pen so that you can see. Right, now, if you have a protractor, this is where it comes into use. If not, don't worry, because you can estimate this, but just try and make them as equal as possible. So I'm going to place my protractor where I've got the cross on my protractor. That's where I want my midpoint that I folded. Measuring it up along my line. Right, now, semicircle, half of a circle. A circle is 360 degrees. So a semicircle, half of a circle is going to be 180 degrees. I need to split that equally into 3 parts. So 180 divided by 3 gives me 60. I'm going to mark at 60, and then 2 60s are 120, so I'm going to mark at 120 as well. Okay, now I can draw my line from my marks down to that midpoint. There we go. Okay, so you can see there I've got 3 equal parts. Now I need to do the same again on the other side. So it should look something a bit like this. Okay. Now, all I've done here is I've stuck it onto my card just to give it a bit more stability. Okay. So, remember we talked about there are 3 primary colours that we need to use in light, and that is red, blue and yellow. So you need to choose 2 of those colours to start off with and colour in the sections alternately. So that means every other one. So you're going to create a little bit of a pattern. Okay, I have chosen yellow and blue. So here's one I made earlier, Blue Peter style. And you can see I've gone yellow, blue, yellow, blue, yellow, blue. Now, the next thing to do is to create the 2 holes to put your thread through. Now, a good tip for this is put something like a rubber or a bit of blue tack underneath just to give you a little bit of something to push against. Okay, you want to put your 2 holes on either side of that midpoint with about a centimetre in between. Okay, so use my ruler. There's going to be 1. So I'm just going to push down, and I've made a little hole. Go back to my ruler. And there's going to be my other hole, pushing down. Now, when you're cutting and doing the pushing, you may well want to ask an adult for a little bit of help. I'm just pushing my pencil through there just to make it a little bit wider, so I can definitely put my thread through. The other thing you may want to do is just put a little bit of tape across the back to reinforce it, just to stop it from tearing quite so easily. There we go. Okay. So, I've just got to undo my knot from earlier. Right. I'm going to take one end of your thread push it through one of the holes. Might need to make it slightly bigger. There we go. Where's it gone? Okay, that's one side. Oh, I've got myself all in a knot now. And then you need to do the same again through the other hole. Again, I need to make mine slightly bigger. Okay. There we go. If you pull the two ends together and make a knot, and secure like so. Right, you should find that you've got a loop at one end, and then you've got a loop created by the knot at the other. Whoops. And your spinner needs to be about halfway between. Now, this is where you are going to need an extra pair of hands. One person is going to hold the rope, the thread, whilst the other person manipulates the spinner. Now, I don't have another pair of hands, so I'm going to loop mine over the back of two dining chairs. Okay, just secured it with a bit of tape so it doesn't fly off. Way through. Okay, so you want string to be relatively taut, not too much give in it. And you can see there, it's not terribly loose. What we're going to do now is take your colour wheel and you're going to twist it. And what you'll notice is that the thread starts to create a bit of a twist as well. We're building up some tension. So keep twisting, keep going until you can't get it to move anymore. Twist, twist, twist. Twist, twist, twist as much as you can. I can start to feel it pushing against me, so I know we're getting close now. Okay. Now, once you don't think you can get any further with it, you won't twist anymore. You can hold. Oh, that's what I meant about it flying off. Get another bit of tape quickly. But I'm sure you could see what happened as it was released. That's what we're aiming for. So just very quickly, a bit more. Oops. Twisting, twisting, twisting. Okay, hopefully I've got that with enough tension on it. So if you stand to the side, you want to watch and see what happens with your spinner. See if you can work out what colour is being created. As you let go, it will spin and it should create a new colour, your complex colour. And that's what we're aiming for. So that's your challenge, to create some colour spinners, to see if you can work out how the different colour lights are mixed. And with an extra challenge, I wonder if anybody can work out what combination you would need to be able to create white light. It's a clue, you may need more than 2 colours. But remember, we're looking forward to seeing everything that you've done by sending it in to us on the class emails or sharing it over Twitter. Happy creating.
So There we go, your extra challenge. As well as creating as many different colours as possible, can you create or construct the spinner that creates white light? We look forward to seeing all of your results, not just from day one, but across the week. Remember, you can show us in any way using technology. So you might have videoed, you might do as we're doing, like a Zoom recording, anything like that that uses technology is brilliant. Have fun. Thank you.